All right, guys, so this is your test review over sections 8.1 through 8.4. And the first couple questions on your test are going to ask you for your own examples. Okay, so the first one says, write an expression that simplifies to c to the 7th using product of powers. So that means c to the 7th has to be your answer. Did anybody come up with their own example? Okay, give me product of powers that would simplify to c to the 7th. Anybody have an example? Micah, what do you think?
C to the 4th power times c to the 3rd power equals c to the 7th power.
Perfect. C to the 7th power. As long as your exponents have your common base of c, because c is in your answer, and 4 plus 3 is 7. Are there other exponent combinations that could have given us that answer?
Yes.
What are they?
1 and 7.
1 and 6. Okay, so c to the 1st times c to the 6th. 2 and 5. C to the 2nd times c to the 5th would also give us c to the 7th. Now give me an expression that would simplify to g to the 30th using power of powers. All right, g to the 30th. William, what did you get? Okay. Kalani, did you get one? Power of powers. That looks like product. Power of powers. Anybody give me one with power of powers? What do you think, Noah? Very good. Because you have one base raised to a power, raised to another power. So g to the 15th power raised to the 2nd power, 15 times 2 gives me g to the 30th. Are there other combinations that could be multiplied that would give me 30? What's another combination?
G to the 3rd power parentheses by 10.
Very good. G to the 3rd power raised to the 10th. And I heard another one. G to the 6th power raised to the 5th power. So as long as you raise one base to a power to another power that multiply together to give you that answer. All right. How would you use powers to simplify this product? How would you simplify this product using powers? And I think your test actually says write the product using powers. How could you write it? 8 to the 5th power, x to the 3rd power, y to the 4th power. No dots and no spaces in between your terms. So I still have people leaving a huge gap between the terms or a dot. Just remember, no dots and no spaces. All right, so there's your first 3 questions on your test. Okay, now we're going to simplify. Well, this slide is really packed with a lot of examples. Okay, this section on your test is 6 questions. So I really tried to mimic the questions that you're going to see on your test. All right. Now, in this section, you have product of powers, you have power of powers, and you have quotient of powers. It's all mixed together. I'm not going to tell you which one it is. So you have to know, when are you going to add your exponents? When will you multiply them? And when will you subtract them? All right, so I want you to go ahead and simplify each of these. Notice that in the instructions, it says that you can write your answer as a power. You do not have to evaluate here. All right, so we're going to pause real quick and let you guys solve these. Okay, what about my A's? What'd you get, Sabrina? A to the 14th power. All right, because it's product of powers, powers with the same base, I add my exponents. What about my negative 3's? Reagan, what'd you get for your negative 3's?
I got
Negative 3 to the 13th power. Again, that's another product of powers, powers that have the same base. What about my x? X squared raised to the 3rd power, William? X to the 6th power. That's an example of power of powers. One base raised to an exponent, raised to another exponent. Marcus, what did you get for your negative 4? Okay, well, what do you think? Very good. It's quotient of powers So we got -4 to the second power. We subtract. I will not take off if you don't show your step 2 on your test. Okay, it's okay to use the mental math. All right, 5.3. 5.3 to the 4th power raised to the 4th power. Anybody have that one? Nias, did you get that one?
I got 5.3 to the 16th power.
Very good, to the 16th power. All right, and then my 6's at the bottom. You do have one of these on your test as well, where you have to simplify either numerator or denominator and then simplify again. All right, so what did you get when you simplified the denominator, William? 6 to the 4th power. And then what did you get when you simplified after that? 6 to the 6th power. Okay, so we're doing good. 6 to the 6th power. How did you guys do on that section? Did you guys do okay? I'll do good? All right, that's 6 questions on your test, so that's essentially 1/4 of your test right there. 24 points out of 100, so it's about 1/4. Okay? All right, so next slide. This is going to be a big one too. There are 6 questions in this section as well, where you're now going to evaluate the expression. That means every exponent that you see, if it has a number as the base, you must evaluate the exponent. Okay, you must evaluate the exponent. So we are actually going to have answers here in this section. Evaluate the expression. All right, so again, we're going to pause for a few minutes and let you guys work through these questions. Okay, 8 squared, that's an easy one. What's 8 squared, guys? 64, all right? Nothing too complicated about that. What about -6 squared? What about -6 squared? What do you guys think? Just tell me. -36, because the base is not in parentheses. You actually have 3 of these on your test tomorrow, okay? So you've got to remember, if the base is not in parentheses, this means -6 times 6. You don't have to write this step, but I want to show you. Your answer is always negative, okay? The negative does not repeat with the multiplication, all right? Quotient of powers here. I do need to evaluate, but I first have to simplify my exponents. So this means 6 to the 2nd power minus 4. What is 2 minus 4? -2. Can you evaluate a negative exponent? No. So what can you do? Put it over 1 and flip it. 1/36. All right. You do have one of those on your test tomorrow. So once you do quotient of powers and subtract, if that is a negative, you have to flip it and then evaluate. All right. So let's see if we can avoid making the same mistake twice. What is -3 squared as it is written here in the slide? What's -3 squared? Yes, there we go. -9 times what's -2 squared? -4 minus 4. What's -4 minus 4? No. -8. Same sign, add and keep. So what's -9 times -8? +72. Okay. All right, what do those bars mean? What are those bars? Absolute value. So -2 squared is -4 because -2 is not in parentheses. But what is the absolute value of -4? Just 4. Just 4. Okay? So because those absolute value bars were there, my answer is just 4. 4 to the -3rd power. Can I evaluate a negative exponent?
No.
No. So what'd you do, Sabrina?
You have to make an fraction and put it
In the denominator. put it in a fraction, and then flip it into the denominator. Now you can do 4 times 4 times 4. Does anybody just remember what's 4 to the third power? Oh, you're so close. 64. 64. So your answer is 1 over 64. I'll definitely try to give you guys partial credit, especially on the negative exponent ones. You have one of those on your test tomorrow. You have one. All right, any questions? All right, so the negative exponents, I do throw them in there occasionally, but the majority of your test is positive exponents. Okay? All right, so now I want you to evaluate these expressions. What's different about what you see here? They have multiple terms inside the parentheses. Does that mean that I only raise the number to the power? Does that mean I only raise the number? No, I have to raise every term inside the parentheses to that power. All right, so we'll pause here for a second so you guys can work these. Okay, 6ab squared. Who got it? Kaylee, did you get that one? All right, what'd you get? Perfect. She raised every term to the second power. No dots and no spaces in between the terms. Just like that. 36a squared b squared. All right, what about the next one? Anybody get the next one? Anyone? William?
100 r squared, s squared, and b squared.
Perfect. We just raise every single term to the second power. All right, evaluate the expression. Okay, so here we've got some negative exponents. This is the last section on your test where it says write the expression using only positive exponents. So we're going to simplify what we can, but then we also are going to use our product of powers, our quotient of powers, but we have to make sure our exponent is positive in the answer. Okay, so what you need to do is you need to somehow combine your common bases, okay? So what's happening here between your D's? What's happening? Is this multiplication, division? What's happening here? It's multiplication. If they're right next to each other, that means multiplication. All right, can y'all simplify that? What would it be? D to the negative ninth power times D to the fifth power. D to the negative fourth power. Negative 9 plus 5, this is product of powers, would be D to the negative fourth power. I'm going to pause here just for a second. How could you write that exponent as positive? Austin, how'd you get it?
If you put a 1 and denominator D.
Uh-huh. And then flip it. 1 over D to the fourth. You guys going to get that one right tomorrow? Okay. All right, now I'm going to throw some numbers into the mix. 5x to the sixth power over x to the negative fourth power. Okay, so I have to simplify my x's. All right, since it's division, I'm going to use quotient of powers. And then I'm going to keep solving. All right, let's see who can get this one. All right, William, how'd you solve this one?
So it's, what you have to do is subtract the negative 4x by the 6.
Yes.
Which means you have to add it.
Yes, 5x to the sixth power minus, so minus is already a part of quotient of powers. But what am I minusing, guys? A negative 4. So it becomes a positive. Did you guys catch the double negative? When you do quotient of powers and you minus a negative, it turns it into a double negative. So this makes it 5x to the 10th power. 5x to the 10th power. And remember, when you subtracted -4, you actually brought those exponent values into your numerator. That's why there's no fraction in your answer. 5x to the 10th power. All right, last one. 6b to the 4th power over 18b to the 8th power. 6b to the 4th power over 18b to the 8th power. Just kind of pause here just for a sec and let you guys solve this one, and then we'll go over it. This is the last question on your test. You do have a review section that we'll go over briefly, but this is the last official question of your test. What is 6 over 18 reduced to? 1 over 3. That was a bad fraction. That's fine. Hold on. So 6 over 18 reduces to 1 over 3. Now 4 minus 8. B to the 4th power minus 8. What is 4 minus 8, guys? B to the -4th power over 3. Okay, so what do? Do I need to flip this entire fraction? Meaning, do I need to put the 3 in the numerator and b to the -4th in the denominator? Does the 3 move? No. It does not have a negative exponent. The 3 stays in the denominator. Okay? How could I make b to the -4th positive? Put that where? In the denominator. 1 over 3b to the 4th. Okay? So you reduce the fraction. You subtract your exponents. The b has to go to the denominator to make it positive, and the 1 stays on top. All right? You do have a review section on your test tomorrow. You don't have the function rule, though. So the output is 8 more than the input. Well, that's x plus 8, but that's not on your test tomorrow. On your test tomorrow, you have to write a function from a table. You have to interpret the slope, and you have to interpret the y-intercept. Okay? That's your review section on your test tomorrow. These questions are 2 points each. Okay? So, how can I write a function from the table? How can I write a linear function from a table of values? What 2 pieces of information do I need to write a linear function? I need the slope and the y-intercept. I need m and b. I need a slope and y-intercept. Well, can I find a slope using a table of values? Absolutely. Okay, I pull out my ordered pairs, 6 and 12. And 8 and 15. Okay, 6 and 12 and 8 and 15. So now find your slope. M equals. What numbers do I subtract in the numerator? Yeah, y2, which is 15 minus y1 over x2 minus x1. What's 15 minus 12? 3 over 2. Okay, so y equals 3 over 2x, but now I need my y-intercept. Could I use the pattern to backtrack these values? Okay, so could I say 4 and 9? Could I go down 2 more and down 3 more to say 4 and 9? Could I say 2 and 6? Could I say 0 and 3? So 0 and 3 gives me my y-intercept, plus 3. Okay? Now, to put the slope into an interpretation, what category did I get my 3 from? Where did I get my 15 minus 12 from? What was that? That was weight. So the 3 stands for pounds, right? So the object, I don't know what it is. The object will weigh 3 pounds after how many weeks? 2. Or you could say the object will gain 3 pounds every 2 weeks. That would probably be the better way to put it. gain 3 pounds every 2 weeks. And isn't that what we see? The object gains 3 pounds. There's my pattern every 2 weeks that passes by. So I'm describing the pattern of values. All right, maybe it's a horse or a dog or something. The animal, maybe we'll call it an animal. Okay, how can I interpret my y-intercept? So that's going to be the ordered pair that has 0 for x. How can I put that into a sentence? Remember, 3 is in what category? Weight. And 0 is in what category? Age, weeks. So we'll call it a puppy. When the puppy is how old? 0 weeks. When the puppy was just born, it weighs 3 pounds. Okay, so something along the lines of at 0 weeks, the animal or object will weigh 3 pounds. On your test tomorrow, it gives you the specific category of what it is. It's not weight and age. Okay, all right, so interpret the slope and y-intercept. That involves those ordered pairs. All right, and that's it for your test tomorrow.